Hi and welcome to another lesson in the physics video series. Today we will discuss the easy way to graphically find perpendicular vector components using the quadrant method. Let's get started. Any vector on an angle can be considered to be the hypotenuse of a right triangle. The legs of the right triangle are perpendicular components to each other. Any vector can be broken down into the two most important components, that which sits on x-axis and that which sits on the y-axis, by simply observing which way does the vector point. It's very easy to determine which quadrant a vector sits in by simply observing this following rule. If you have a vector that points up and to the right, it would sit in quadrant 1. If the vector points up or to the left, that sits in quadrant 2. If the vector points down and to the left, that would be quadrant 3, and down and to the right is quadrant 4. All vectors, except those that sit on x and y exclusively, have to be in one of the four quadrants. Let's take a look at this picture to see the resolution of a vector in quadrants 1, 2, 3, and 4 respectively. Here is a vector A, and we placed it in quadrant 1 so that you would see that when it is resolved into perpendicular components, this vector A, which points to the right and up, would sit as the hypotenuse to the blue and orange vector. The blue vector, positive AX, points to the right, and the orange vector, positive AY, points up. It is obvious that this dashed line A, which is now the shadow of the original vector, has been resolved into its two perpendicular components. In the second quadrant, we have vector A pointing to the left and up. The blue vector is negative A on the x-axis. The orange vector is positive A on the y-axis. This dashed line, again, is the shadow of the original vector A, which has been resolved or dissolved into its two perpendicular components. In the third quadrant, we have a vector pointing to the left and down, and so it has a negative AX component similar to quadrant 2, but its AY component is negative, which is the opposite of quadrant 2. So it is pointing to the left and down, whereas quadrant 2 was pointing to the left and up. Quadrant 4 is very similar to quadrant 1, except that in quadrant 4 we're pointing to the right and down, whereas in quadrant 1 we pointed to the right and up. Again, in quadrant 4, this shadow dashed line is the remnant of the original vector, which has been resolved into two components that are perpendicular to each other, positive AX pointing to the right and negative AY pointing down. Recall the components AX and AY are equal to the full vector A times the cosine, which is adjacent, and the sine, which is opposite of the angle. We normally measure vectors off of the x-axis, as is customary in math class. Let's practice by resolving this vector in the first quadrant. Step 1. Identify the quadrant that the vector is pointing. We could see that this vector A is pointing to the right and up, which makes it a first quadrant vector. Therefore, we make this vector A the hypotenuse of a right triangle. Doing that, we draw a positive AX component and a positive AY component. We have resolved the vector into perpendicular components by completing a right triangle. Solution of many vectors is an incredibly important skill that you'll need to do to combine numerous vectors into one group of X components and another group of Y components to take a Pythagorean of the total X and the total Y components respectively. This skill will be used in the force vectors chapter and will be carried through for the rest of the year wherever vectors are concerned. We're always going to be interested in resolving vectors that are on an angle into their X and Y components. In closing, let me show you a quick trick to recall how to find perpendicular components for a quadrant 1 vector. We know that the horizontal component of a vector is related to the cosine of the angle because it is adjacent, and we know that the vertical component of the vector is related to the sine of the angle because it is opposite. The opposite vector points up and the horizontal vector points to the side. So we say, sign me up for a wagon ride and I will coast along the horizontal. And you can see with this mnemonic, sign me up for a wagon ride, that the up vector is the sine of the angle, and you can see that the coast, COS, is along the horizontal. And this little trick was developed to help students remember which way the horizontal component and the vertical components point, and which association of horizontal to cosine and vertical to sine are always connected to quadrant 1 vectors. I hope you enjoyed this video, and I thank you for watching. I'll see you in the next video.